Today we're learning about angles of a triangle. Before we begin the notes, there's a warm-up section. This warm-up section deals with parallel lines and the parallel lines theorems that we went over in the previous unit. So just a quick refresher, you have alternate interior angles, you have same side interior angles, we have corresponding angles, we also worked with linear pairs, and lastly we worked with vertical angles. There were a few more, but these are the ones that help you solve for missing measures. If you forgot what they are, then please refer back to your Unit 1 notes or look back on GoFormative to see some of your work. But you're going to need to use these and apply them to this warm-up problem. Please press pause on your video, try to complete the warm-up, find the missing measurements, and then come back to the video and check out my answer. The first theorem that we're going to go over today is the triangle angle sum theorem. So this theorem states that the sum of the measures of the angles of a triangle is 180 degrees. That's telling you that if you add the measure of angle A plus the measure of angle B plus the measure of angle C, they will equal 180 degrees. Using this theorem, let's look at the first example. So this first example, we see we have two triangles. Well, I guess you could say we have one larger triangle here, and then you can break the triangle into two smaller triangles. So multiple ways to look at this figure. But either way, we're looking to solve for angle 1, angle 2, and angle 3. So I'm going to start with the measure of angle 1, and I'm going to use a previous theorem that we've learned about. So the measure of angle 1 plus 57 is going to form a linear pair, or it's going to add to 180 degrees because it's a straight angle. The measure of angle 1 plus 57 is equal to 180. Subtract 57 from both sides, and the measure of angle 1 is equal to 123 degrees. And underneath that, I'm just going to indicate that we used the linear pair theorem. Okay, now that I know the measure of angle 1 is 123 degrees, I'm now going to work on solving for the measure of angle 2, and I'm going to use the triangle angle sum theorem for that. Here's the triangle that I'm dealing with. We know that two angles inside of the triangle are already given to us. I see that I have 57 degrees and 71 degrees, and I'm looking to find the measure of angle 2. So 57 plus 71 plus the measure of angle 2 is equal to 180. I know this because of the triangle angle sum theorem. All the interior angles of a triangle add to 180 degrees. 57 plus 71 is going to give us 128 plus the measure of angle 2, and this is equal to 180. Subtract 128 from both sides, and the measure of angle 2 is equal to 52 degrees. Underneath this, I'm going to indicate that I use the triangle angle sum theorem. I used the fact that the interior angles of a triangle add to 180 degrees. Lastly, I'm going to solve for the measure of angle 3, and the measure of angle 3 falls within this smaller triangle here. You could also use the larger triangle, it just is a little bit more work if you do that. So I'm going to use the smaller triangle I highlighted in pink, or I traced over in pink. And I'm going to recognize that I know this angle is 123 plus 28 plus whatever angle 3 is going to add to 180 degrees because the interior angles of a triangle sum to 180 degrees. So we have 123 plus 28 plus the missing measure of angle 3 is equal to 180. (123) plus 28 is 151 plus the measure of angle 3. When we subtract 151 from both sides, our solution is that the measure of angle 3 is equal to 29 degrees. And again, I'm going to indicate that I use the triangle angle sum theorem to solve for this. Interior angles of a triangle sum to 180. Now, there were a few other ways you could have gone about solving these missing angle measures. This was what I saw to be the easiest, fastest method, but you could have solved another way. And if you did that, that is completely fine. But no matter what, these are your answers. Number 2 is a bit more complex because we're looking for a lot of missing angles. We have 4, 5, 6, 7, 8, and 9 that we have to solve for. We also see that there's multiple figures within this one single figure. I see a triangle here, I see a triangle here, another triangle here. I could look at it bigger. I could do this whole side as a triangle. I could do this whole side as a triangle. There's so many different ways you could break this apart and so many different ways that you could solve for these missing angle measures. So what I'm going to do is I'm going to go through them one at a time. You might do something different if you want to try this by yourself. But once again, no matter what you get for your angle measures, those are the, or whatever I get for the angle measures, those are the answers. So there's only one answer to this problem, multiple ways to get there, but only one answer for each of these values. Okay, I don't think I can quite work in order on this one because of the nature of the problem. So I'm actually going to start with angle 7. The reason why is because I see this smaller triangle here, and I see that I already have 2 angle measures. So this third angle measure will add or sum to 180 degrees. So this is going to be my first step, and I'll just make I'll make a little note. So the first one we're solving for is going to be angle 7. All right, measure of angle 7 plus 58 plus 65 is going to equal 180 because of the interior angles of a triangle. The measure of angle 7 plus 123 is equal to 180. When we subtract 123 from both sides, we're left with the measure of angle 7 is equal to 57 degrees. I'm going to make a note that this is the triangle angle sum theorem as far as how we solved for it. Okay, from previous theorems that we've worked with, if we know that the measure of angle 7 is 57 degrees, we have a vertical angle right here, so we know that the measure of angle 5 is also going to be 57 degrees, and that is from or because of the vertical angle theorem. Now I'm going to switch triangles and I'm going to focus on this smaller triangle here. I can easily solve for the measure of angle 4 because we have 67 plus 57 plus the measure of angle 4 is going to equal 180 because of the triangle angle sum theorem. When I add these together, I have the measure of angle 4 plus 124 is equal to 180. Subtract 124 from both sides, and the measure of angle 4 is equal to 56 degrees. I'll put my note off to the side that this is because of the triangle angle sum theorem. Okay, So far we've done angle 7, angle 5, angle 4. I am now going to notice that I could, let's see, I can solve for the measure of angle 6 because angle 7 plus angle 6, they form a linear pair. These two angles form a straight line. So I'm going to indicate that 57 plus the measure of angle 6 is equal to 180. When I subtract 57 from both sides, I end up with the measure of angle 6 is equal to 123, and this is because of the linear pair theorem. And lastly, we need to look at angle 8 and angle 9. So notice how these two angles have this mark here, which indicate that they are equal. So within this triangle, I know that I can add those three angles to 180 degrees. And I forgot to mark that angle 6 is 123. Okay, so I know those three angles sum to 180 degrees. So I'm going to write out that 123 plus the measure of angle 8 plus the measure of angle 9 is equal to 180. And just bear with me for a moment. I'm going to write the measure of angle 8 and the measure of angle 9 both as the variable x because they are both equal to the same thing. So I'm going to write a note and I'm just going to say because the measure of angle 8 and the measure of angle 9 are equal, I replace them with the variable x. That means I'm going to write 123 plus x plus x, I'm replacing each angle measure with x, is equal to 180. I'm going to subtract 123 from both sides, and I'm also going to rewrite this as 2x is equal to 57. I divide both sides by 2, and x is equal to 28.5. So if x is equal to 28.5, that indicates that both angle 8 and angle 9 are equal to 28.5. And that's all of your missing angle measures. When you get a problem like this, you have to work around to solve for all of the angles. You might not do it the same as me, but you have to end up with the same answers as me. However you go about doing this, or whichever order you go about doing this, is completely fine. Just show your work and support your reasoning. Next, let's take a look at this diagram with a couple of definitions. So we are looking at exterior angles, and exterior angles are formed by one side of the triangle and the extension of an adjacent side. So exterior angles of a triangle fall in this area here with this particular triangle. So they're formed by one side of the triangle. That would be this side. And the extension of an adjacent side. So here's an adjacent side because it touches. And once you extend it, we just formed this area in here. Okay, we could swap, oops, and we could say that, let's see, this is our side of the triangle. This is our adjacent side, so when we extend it, it comes out this way. And now with that extension, here are your exterior angles. You could keep working around the triangle and you could keep creating different sections of exterior angles. We also have remote interior angles, and each exterior angle of a triangle has two remote interior angles that are not adjacent to the exterior angles. Okay, here's your exterior angle in my model. It's angle 4. Angle 2 is the adjacent angle. So that is not a remote interior. Your remote interior is going to be angle 1 and angle 3. It's the two angles that do not touch your exterior angle. So in our model, I'm going to say angle 1 and angle 3. Actually, in the above section, let's add that our example would be angle 4 as well. So use this as a model. You might be a little confused by it at this point, so it should make more sense once we go through the examples. So with that said, let's scroll down and start looking at the theorem, and then we can go through the examples to better explain what interior and exterior angles are. So the exterior angle theorem states that the measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. So in this model here, angle 1 is our exterior angle. Okay, it's formed by this side of the triangle and this adjacent side of the triangle. If angle 1 is our exterior angle, the two angles that do not touch angle 1 are called your remote interior angles. Now your exterior angle is equal to the sum of your remote interior angles. So that's telling us that angle 1 is equal to angle A plus angle B. Looking at number 1, I'm going to label what I have here. I know that 112 is my exterior angle. I'm just going to abbreviate it as exterior. I know that 32 and 2, or angle 2, are my remote interior angles. So I know that the two angles in pink add up to my one angle in orange. So I can say that 32 degrees plus the measure of angle 2 add together to equal my total angle measure of 112, which is right here. Subtract the measure of angle 2 from subtract 32 from both sides, and the measure of angle 2 is equal to 80 degrees. So just a quick note while we're on this one. There's a lot you can do with these triangles. Of course, we're working with a specific theorem, but don't forget that this right here forms a straight angle. So if by chance you were asked to find this angle here, this would be, or these two angles, this angle and this angle, would sum to 180 degrees by the linear pair theorem. So you can still find this angle measure, you just don't find it using this particular theorem. You find it using the linear pair theorem. That would allow you to solve for the triangle in another way, because then you could end up using the triangle angle sum theorem to find the three interior angles. So when I say there's multiple ways to solve, there are so many different ways to solve. You just have to make sure you pay attention to all the different theorems, postulates, definitions, everything that we go over can be applied to these diagrams. Okay, and moving on to our last example, number 2. In this example, we are looking to solve for the measure of angle ABC. So the measure of angle ABC is this angle here. I'm going to indicate where it is in pink because it's called a remote interior. Our exterior angle is located right here. So I'm going to go about solving this the same way as what I have been doing. I'm just going to have to find our value of x first, and then I can substitute that back in to find the angle measure of ABC. So I know that my angle C plus the measure of angle B, which is ABC, is equal to my exterior angle, which is, I'm going to just list it out as 148 degrees. Now I'm going to replace the measure of angle C with the expression that's given for that angle. That's 2x minus 15. I'm going to replace the measure of angle B with the expression x minus 5. And I know this is equal to 148. Combine like terms. I have 3x minus 20 is equal to 148. Add 20 to both sides. 3x is equal to 168. Divide both sides by 3. X equals 56. Now this is not my answer because my answer is asking me for the angle measure of angle ABC. So the measure of angle ABC is represented with the expression of x minus 5. I'm going to substitute x as 56. 56 minus 5 gives me the solution for the measure of angle ABC, and that gives me 51 degrees. This here is my final answer. Please let me know if you have any questions, and that's it for the note sheet for today. Have a nice day, everyone.